Good evening. Today is Monday, December the 7th. Today in pre-calculus, we looked at solving trigonometric equations, and that's what we've been working up toward using all of the identities that we've learned and trying to verify identity so that we get comfortable with the using of the formulas so we can solve equations. So I'll share the screen here and show you a couple of examples of what we did. So when you are solving trigonometric equations, first off, we will say in a lot of cases you have a requirement to solve them for all values over the whole domain. But in this case, in most cases, we will be looking at the interval from 0 to 2 pi. So that will be a one trip around the unit circle. And we'll put a closed interval here. Now, sometimes you'll have an open interval on this 2 pi, which means 2 pi will not be included if you have an answer which is 0. So the different types of equations, the first one we got here is just basically something like, we come over here to text, and we say, okay, we've got cosine x times sine x equals 3 times cosine x. Now, the tendency would be here to cancel the cosine x's because you have one on each side. But anytime you take and cancel something, cancel a term that has the variable in it, you're running the risk of throwing away some of your solutions. So what we will do instead, we will bring the 3 cosine x across the equal sign and put a minus in front of it, and then set it equal to 0. Now, so at this point, if you'll notice what we can do, since we have a cosine in both of the terms, we can factor out the cosine x, and then we have sine x minus 3 left, and that's equal to 0. So we got a couple of solutions here. We can say, okay, cosine x equals 0, or sine x minus 3 equals 0, which means sine x equals 3. Now, if you'll remember what we learned about the sine and cosine function, the range of the sine and cosine function is from -1 to 1. So if you try to put an inverse sine of 3 in your calculator, you would get an error message because the sine of x cannot be 3. So there are no solutions to that part. Now the cosine x equals 0, if you remember your unit circle once again, and your x coordinate of your unit circle, see, so if you draw your unit circle here, and you got your x coordinate, remember, is your cosine. Here it's 1. So you have 1 and 0 there. You have 0 and 1 up here at pi over 2. You have -1 and 0 over here at pi. And you have 0 and -1 down here at 3 pi over 2, and then back to 2 pi. So if you look at the cosine being 0, the cosine is 0 up here. So my answers here are x equals pi over 2 and 3 pi over 2. So these, if you'll notice, these trigonometric equations work just exactly like algebraic equations as far as your algebraic operations. But once you get to this point right here, normally you have an x equals and an x equals with an algebraic equation and you're finished. But with the trigonometric equation, you got one more step to figure out what's going on. Now, the thing, if you're looking at most of your equations that don't end up being 0, something like this, if you go back to your, let me do that again. Okay, I'll go over here and do this with the straight. So you can see, you remember you've got your 30, 60, 90 triangle and your 45, 45, 90 triangle. So here, your 30, 60, 90 triangle, this would be your pi over 3. This is your right angle here. And this would be pi over 6. So you got a 1 here, you got a 2 here, and you got a square root of 3 here. Now, the other triangle, remember, is your 45, 45, 90 triangle. So you come down here, you got your 45, 45, 90 triangle. This is the pi over 4. So this is pi over 4. So when you work these trig equations, normally you will come up with something that says, okay, what sine of something equals a half, or sine of something equals square root of 3 over 2, or sine of something equals 1 over the square root of 2. So those are those two triangles here you have to be very familiar with. So those are the triangles. I'll leave them there. Now, the next thing I'm going to do, I'll show you a different equation. So I'm going to try to leave the triangles up there. If you need to look at this, pause the video, and I'm going to erase it so I can get rid of this, get rid of this, get rid of this. Now, so I've got my reference point, I've got my circle here, and I've got my two triangles. So here's my next equation. If I come in here and say, okay, I have cosine to the 4th power x plus cosine to the 2nd power x minus 2 equals 0. Now, if you look at this, what you have here is the same thing you would have in a algebraic equation if you were looking at something like x to the 4th plus x squared minus 2 equals 0. See, it's the same thing, except your base now is cosine x instead of just plain x. So when I factor this, I'll come down here and I will have cosine squared x plus 2, because the bigger one is plus, and then I would have cosine squared x minus 1, and I set that equal to 0. Now, once again, see, if I do this one here, I would get cosine squared x plus 2. Now, if you look at cosine squared x plus 2, that's positive. That's positive. So this expression here can never be 0. So that right there, you know it won't work. You can just kind of put a slash through it like that. So over here you have cosine squared x. So we'll go back to our text here. So we have cosine squared x equals 1. So that means cosine squared x cosine x equals plus and minus 1, which is just basically okay. So plus and minus 1. Now, once again, if you look, see, so your equation here, cosine squared x equals 1, so cosine x equals plus and minus 1. Cosine is your positive, or is your x coordinate. So if you look back over here at your unit circle, one of the solutions here is 0. So we have x equals 0. put that minus there. So get rid of that minus. Okay, so one of your solutions is 0. And of course, if you have 0 and you have a closed interval here, then 2 pi is also a solution. But the other solution, which is your minus 1, is over here at pi on the other side of the circle. Okay, so that's the second type of equation. Now, one other type of equation I want to show you here. So once again, I'm going to erase what I have here. If you need to pause and look at it, do that. And then we'll come back and we'll erase like this. So now the equation I'm looking at now is going to be 2 cosine squared x minus sine x minus 1 equals 0. Now, what you'll notice here is you have a cosine expression and a sine expression, and you can't solve a trig equation with two different trig functions in it. So we're going to get rid of the, if you remember here, I'll write out the identity that we use. We have sine squared x plus cosine squared x. Anytime you're trying to get rid of sine squared or cosine squared, this is the identity you're going to use. So sine squared plus cosine squared equals 1. So in this case, so I can change the cosine square. So I will go back to text here, and I can change the cosine square to 1 minus sine squared. And I have my minus sine x minus 1 equals 0. Now, so if I distribute, I get 2 minus 2 sine squared x minus sine x minus 1 equals 0. And what I like to do is bring this across to the right side so that there is a positive. So I'm going to have 0 equals 2 sine squared x plus, come on, I want to get the equal sign, plus sine x, and then I've got a plus 1, so that's going to be a minus 1. So I'm sorry, so I'm going to start over again here. 0 equals 2 sine squared x plus sine x minus 1. Okay, now, and then I can factor this just like we would factor it if it were an algebraic equation. So I have 2 sine x, and then my plus has got to be in the middle, so I've got to have a, this is going to be a minus 1 times sine x plus 1. Now, so if you look and you check, you always get check 2 sine x squared, and then I got 2 sine x minus 1. That's okay. So I'm good here. But now in this case, if you'll notice now, so if I set each one of these factors to 0, I get the first one here is going to give me sine x equals to 1/2. And the second one over here is going to give me sine x equals minus 1. Now, so this will help me out here. So my answer, see, so x equals, so sine x equals 1/2. Now look, I go over here to my pi over 3, pi over 6 triangle. The angle whose sine is a half is pi over 6. So one of my answers is pi over 6. I'll write this as pi divided by 6. Now, and if I have an answer here, so if I have an angle right over here, which is pi over 6, then I also have an angle right over here with the same reference angle. So if this angle is pi over 6 and this is pi, then that's 5 pi over 6. So I'm going to come back down to here. So my second part is 5 pi divided by 6. And then that takes care of the 1/2. But now the sine x is -1. And once again, the sine is the y coordinate. So I look here, and the sine is the y coordinate. So I would also have an answer of 3 pi divided by 2, which is here at the bottom of the circle. Okay. Now, so that kind of shows you the different types of problems we looked at today. I'll stop sharing here. If you look at your homework, if you have any questions, send me an email and I will help you get over the hurdle. Now, the schedule this week, if you look, we're going to finish up this section tomorrow. And then on Wednesday, we will be doing the mid-chapter quiz for chapter 5. So you need to get that done and get it in. And then if you're a senior and you're exempt, Thursday will be the last day. Otherwise, I've put the study guide for the first semester test in the OneNote so you can look at it and start to review. And I will get back with you tomorrow again and show you the other types of equations that we looked at. So hope you're feeling better, and I'll see you tomorrow.